Welcome to Kirkwood School District 6th grade science. We're going to take a look at the states of matter. Our goal here is that students will be able to describe matter based on the movement of particles. So not only will they know solid, liquid, gas, etc., but they'll know why exactly a liquid is a liquid and what exactly is going on with the movement of particles. There are three states of matter: solid, liquid, and gas. And there are a ton of examples of all those things that are solids, that are liquids, and that are gases. But often we look at them and don't really understand what's going on with the particles inside. So take a look at this video to get your brain ready to go and thinking about those particles.
The states of matter are gas, liquid, and solid. Gases assume the shape and volume of their container. Particles of a gas are separated from each other, move in straight lines, and in a completely random manner. They change direction only when they collide with each other or the container. Liquids have a definite volume and assume the shape of their containers. The particles of a liquid are closely spaced, and so their motion is still random but much more limited. The particles slip past and collide with near neighbors. Solids have a definite shape and volume. Particles of solids are in fixed positions and collide only with near neighbors.
All right, so there you got to see a little bit about each of the particles. So let's continue and take a look at that. A solid is any object with a definite shape and definite volume. It describes, when you describe the particles, they're described as having a fixed position, closely packed, and their drawing looks a little bit like the one you see with the little blue arrow. Each of those particles can vibrate, they can spin, but they can't move out of that fixed position. There are two types of solids: ones that are really well organized, called crystalline solids, and some that are less organized so well, called amorphous. A liquid has a definite volume but no definite shape. Those particles, as you can see here, they're kind of loosely bonded but free to move as long as they stay in contact with the particle next to it. They have the ability to kind of slide all around one next to another. A gas is a fluid. It's a substance that flows. There's no definite volume, no definite shape. The particles are spread up. They fill the container. They're not connected to one another. And as they continue to increase speed, they increase the distance in between each of those particles. Now, when you go from one state or phase of matter to another, that process involves either adding heat or energy, or taking heat and energy away. So think about that as we continue to talk about these different topics. Melting, changing a solid to liquid. The melting point is the specific temperature that the melting occurs. When melting occurs, the particles begin vibrating so fast that they break free from their fixed position. Freezing is the opposite. Energy is taken away. It's the same as the melting point, but it's losing energy instead of adding to it. Particles continue to slow down, particles move slower, and they form patterns or become closer and closer together to that fixed position. Vaporization is a changing of a liquid to a gas. Vaporization takes place when the particles in a liquid gain just enough energy to break free and become a gas. This occurs at what's called the boiling point. Evaporation is different than vaporization because vaporization only occurs at the surface. Okay? Vaporization that only occurs at the surface is called evaporation. So if you imagine boiling water, the boiling water comes up from the bottom and vaporizes. Evaporation takes place at the surface of the water and takes place simply by a concentration gradient of that liquid and the air that's surrounding it. So how is it different than vaporizing? Well, vaporizing requires boiling. And boiling is when vaporization occurs below the surface as well as above that. Condensation is what happens when a gas changes into a liquid, and this happens because of a decrease in energy. Particles slow down, lose enough energy to form those loose connections. Sublimation is an exciting process. This is where you've seen it in dry ice. You can see it there in that picture. When you go from a solid straight to a gas because so much energy has been added that you skip the liquid phase altogether. The particles speed up, gain so much energy that they break free from one another. A sort of summation of this is you can set them all down into a diagram and take a look at gas, liquid, solid, and talk about is energy or heat being released or absorbed? Which way is the energy going? And also another good topic to do with this exact same diagram is what's happening to the particles. Are the particles speeding up? Are they slowing down? Okay, so when you're looking at this picture, think of all, not only the particles, but also what's happening with the amount of energy those particles have. So our goal today was students will be able to describe matter based on the movement of particles. So when we're thinking about solids, liquids, and gases, don't just think about them. Think about what's going on with their particles and how their particles are being arranged or how they're moving. Let's check this video out to wrap up this session together.